Directly proportional is a term that could come up in your exam, so you might be asked about it, or you might actually be asked to decide if data is directly proportional. It's a term you might have to use. The symbol for directly proportional is this. So if I wanted to say X was directly proportional to Y, that's how I could write it. You do need to know the symbol. Now, directly proportional means that if you've got a set of data, as one amount increases, another amount increases at the same rate. I will show you what that means in a second with science data, but it normally means if you've got a table of data with two columns, if the number in one column doubles, the number in the other column should double. If the number in one column triples, the number in the other column should triple. If the number in one column halves, the number in the other column should halve. So I'll show you what that looks like. So, real exam question. The students made the following hypothesis. The mass of copper deposited on the negative electrode will be directly proportional to the current. The table below shows the students' results. Now, this question's about electrolysis, but you don't need any knowledge of electrolysis to answer it. You just need to know what directly proportional means. Now, student A said the results did support the hypothesis. So student A thinks that this table does show directly proportional, but student B says it doesn't. Explain the extent to which the data in the table above supports the student's hypothesis. Now, I said that data was directly proportional if when one column doubles, the other doubles. So if you look, this column starts with 0.12 and it doubles to 0.24, so times 2. That means the same change should be seen in this column if it is directly proportional. 0.024 should double to 0.048. So that's not quite double. It's nearly double, so I can see why student A thinks that, but it's not quite double. Now, if we go again, if we go 0.24, and then that would double by going down those two columns, so that would be double, so that would be times 2. So that means from there to there, it should double. Well, double 47 or 0.047 is 0.094. Again, it's very close, but it's not quite double. So technically, student B is correct. It's not directly proportional, but it is very close, which is why student A thinks it does support the hypothesis. But that's how I check. So I would say student B is correct because when current doubles, mass does not quite double. But I'm going to make a point, but it is very close. So I can sort of see why student A thinks that. But that's how I check a table for if it's directly proportional. Now, another way to tell if something's directly proportional is from a graph. Some people say it's easier to tell from a table, some say it's easier to tell from a graph. But ultimately, if I double one, does it double the other? So if I just look, well, 1 comes to about there. If I double it to 2, it comes to about there. Now, if I check my numbers, that's 0.025 and that's 0.05. It has doubled. This is directly proportional. However, I don't actually need to check numbers like I just have to tell. any graph, I can say the data is directly proportional if it is a straight line, which this one is, through 0. It must go through 0 to be directly proportional. This one does. So what I could say about this graph is I could say that force is directly proportional to extension. I use the labels on the graph. So force is directly proportional to extension. Or saying it with the symbol, I could say force directly proportional extension, just in case the symbol comes up. So that's how you pick up your marks with directly proportional.